Check this out. There's a giant tornado heading towards you, and it's so fast. These twisters can move at crazy speeds of more than 250 miles per hour. Plus, they can carve a pathway 50 miles long and a mile wide. Sometimes you can see them coming clearly, while in some cases, low-hanging clouds or rain can hide them, so they sneak up on you and you don't even see them. And in most cases, a tornado can develop so fast that no one can even warn you in time if it's already too close. And now, this insane storm is really close. Maybe you have a couple of minutes to get somewhere safe. Do you have a basement? Go hide. Or maybe, I know this is a crazy idea, but what do you think about going inside a tornado to check what it would be like? Now, some tornadoes appear as rope-like swirls, while others have wide clouds in the shape of a funnel. And here's the second one, right before you. Look at these whirling winds born in a thunderstorm. They extend down from it to the ground. Many times, hail joins the party too. The U.S. itself has something like 1,000 tornadoes per year. Texas holds the record with about 120 tornadoes per year, a record not to be proud of. But you'll generally see most twisters in Tornado Alley, which is a stretch of land in the midwestern part of the U.S. They develop when warm, moist air coming from Mexico meets cool, dry air from Canada. These two clash and turn into a powerful storm that at some point can spawn tornadoes. And you'll see most tornadoes there between April and June, though lately some have come even in December. They can range from a regular dust storm to an incredibly powerful force that can carry away cars, large trees, and even houses. But this is a unique chance. You've never been this close, right? Plus, it's a gigantic one. You don't often get to see such a big one. Okay, ready then? It's getting closer. You feel the wind getting stronger while tossing dirt and debris in your face. You close your eyes and whoosh! You're inside, and it's crazy. Vicious winds are hurling and spinning you around. They're lifting you up at the same time. Feeling dizzy? Feeling like Dorothy from The Wizard of Oz? Now may be a good time to check what's really happening to you, while inside swirling with winds and… oh wait! Is that your neighbor's motorcycle spinning together with you? Hope it'll stay that far away. Now, let's take a moment to catch up. Being in the middle of a raging tornado is actually something you might survive. But I won't lie to you, it won't be easy. The first thing you'd sense would likely be the temperature changes. Inside this crazy twister, it can be 36 degrees colder than outside of it. That's because the center of the tornado funnel spins all the time. All that funneling makes the inside of the vortex way colder, and it makes the air way thinner than you used to. The air would be 20% less dense than, for example, what you would find at high altitudes. Now, I hope you're not planning to stay there for too long. Disclaimer here, the atmospheric pressure inside this swirling vortex is so low that your lungs won't be able to extract enough oxygen. Now, to give you a perspective of all this, breathing inside a tornado is like trying to get some air at an altitude of 26,000 feet. That's a pro level, similar to climbing Everest. So yeah, you'll need some help just to be able to take a regular breath. In short, you'll probably pass out after only a couple of minutes. But don't worry, I brought you this special mask, so breathing is not a problem anymore. Hey, did you notice how smooth the airflow from the inside is? Some storm watchers ended up inside a tornado. Later, they said it all looked so chaotic with all those raging clouds and winds swirling around. But from the inside, the air is surprisingly smooth. But that doesn't mean you'll get a peaceful ride because of it. And it's not a solo party in that thing. The neighbor's motorcycle is not the only thing you'll see there. Wood, bricks, glass, maybe even cars, cows, motorhomes, bricks, roofs, and other big objects. You'd be pretty lucky if nothing crashes into you in all that chaos. With all that debris that's swirling at, for instance, 310 miles per hour, you can hardly avoid it. But let's just say a miracle happens and you got through it. Now you're really dizzy, and you're just wondering when all of this is going to be over and if you're even going to be able to come out of this gigantic tornado. Well, the tornado will eventually slow down. It happens because cool air enters the twister. Just because things are settling down, it doesn't mean you can relax. Well, your stomach can, since all that crazy swirling is done, but the tornado will drop you from whatever height you're on when it stops. If you're somewhere in the countryside, there might be some soft bale of hay to break your fall. Oh wait, we're talking about a twister that's probably more than 45,000 feet tall, so that won't work. I hope you brought your parachute, because now would be a good time to pop it. Nope. Hey, don't worry. I'm all about happy endings, so I'll help you out. Here you go. And now you're slowing down, enjoying the view, if you even see anything around you from all that dizziness. How come there are clear sunlit skies from your left, you may wonder? It's not unusual. Tornadoes often form near the edge of a thunderstorm. It's like a border between two different worlds. And it wasn't even windy. Plus the air was very still before it hit, right? Well, that's common too. Okay, I think you know this kind of scenario is impossible in reality. So it would be best to find a safe spot quickly if a tornado is close by. Use your underground shelter first. And if you don't have one, your basement could be the next best choice. Prepare ahead of time with a battery-operated TV or radio, together with fresh batteries, or a device with internet to be able to hear the latest updates on the tornado. Include some non-perishable food, water, and other essentials prepared too. As it turns out, some people really were picked up by tornadoes, and they managed to go through it. A tornado actually dropped them a few hundred feet away without a scratch. Hey, I'd say that's a whole lot of bother just to save some bucks on Uber. But you can't have a guarantee you'll be safe or where you'll end up. It would be incredibly hard to get out of one of those big and fierce ones, though, like supercells. They fall into the category of the strongest type of storms, mostly thunderstorms. And imagine falling into waterspouts. Those could be fine, though, at least the beginning, because they're weak and they form over warm water. So they could be like a part of your spa day, at least until they move inland and turn into a real tornado. Now, dust devils wouldn't be that pleasant. They're not that big, but we're talking about columns of air that rotate at large speeds. And you can easily see them because of all that dirt and dust they pick up, which is why you need glasses for that. Whoops, wait, I forgot that, so I can't help you this time. But if it makes you feel any better, they're not associated with thunderstorms. Don't know why that would make anyone feel better when I think about it. But if you're willing to jump into a fire tornado, I'll find you a special suit that will keep you safe while spinning through smoke, gas, and flames. I promise. Columns here are narrow and they rise vertically into the air, similar to a dust devil. Of course, the heat is crazy. And as updrafts are becoming stronger, and if there's enough dry fuel, a fire whirl is turning into a real fire tornado that extends from the ground up to the cloud, moving incredibly fast. Okay, let's stop now. I'm pretty dizzy.
Bright, colorful flashes of pink and green light up the sky. You're watching it from your backyard in Pennsylvania. That's not something you're used to, but it's very likely to happen more often in the near future as the northern lights are shifting south. Northern lights, or auroras, appear as a result of solar storms. The sun is a huge ball of molten gases that are constantly moving, so such storms aren't rare. Our star produces a huge amount of energy that goes our way. It travels as electrical charges at the speed of about 3 million miles per hour, no big deal. When all those tiny particles from the sun reach Earth's atmosphere, they give some of the energy to atoms and molecules in its upper layer. The atoms and molecules can't hold it and give it off as light. You can see it as spectacular auroras around the magnetic poles of the northern and southern hemispheres. If you were watching them from space, they'd look like large ovals. The brightness, colors, and shapes auroras take depend on the altitude where the lights are formed and what particles take part in the process. In the Northern Hemisphere, locations like Alaska, Canada, and much of Scandinavia normally get to see the brightest lights. The biggest solar storm ever was recorded in 1859, and it was so powerful that the northern lights were spotted in Cuba and Honolulu, and southern lights were seen as far up as Santiago, Chile. In latitudes like that of New York, people were able to read newspapers in the dark under those northern lights alone. If something similar happened today, it would have caused $1 to $2 trillion in damage. With solar activity and pressure from the solar winds increasing, the aurora belt's borders are currently shifting south. Solar activity goes in cycles, each of them 11 years long. We're now in solar cycle 25, which started in December 2019, and will reach its maximum strength between November 2024 and March 2026. So, geomagnetic storms will become stronger and probably even reach G5 levels. Those levels are their strength ratings. For you to see the northern lights south of the Great Lakes, a storm must be rated at least G3. G5 storms will be able to produce auroras that will even reach Florida. In case you don't want to wait for the sun activity to peak in 2025, head north if you're in the northern hemisphere, or south if you're in the southern hemisphere. Auroras down there are known as the southern lights, or aurora australis. It doesn't have to be cold for you to see the northern lights, it just has to be dark. Auroras are active throughout the year. You can't see them from April to August in the northernmost parts of the world because it's light 24/7. It's also important that there isn't any precipitation or clouds in the sky. Those will block your view. Light pollution won't help either, so move away from any cities. Try to get to an elevation to maximize your chances of spotting the lights. They can appear in a whole variety of colors, including white-gray. The green-yellow part you're most likely to imagine while thinking of the lights is just the easiest to spot with an unaided human eye. Sometimes you might not see the lights at all, but your camera will still catch them. They might seem dangerously close to Earth, but the closest the northern lights ever get to us is 50 miles. For comparison, planes normally fly at around 6 miles above the surface, and that already seems like a lot. The distance from Earth defines the color of the auroras. When atoms giving us this spectacular show collide closer to Earth, you can see blues and violets in the sky. Green and red auroras are born further away from our planet. Earth isn't the only planet to have northern lights. Jupiter and Saturn both have strong magnetic fields, and scientists spotted auroras up there using the Hubble Space Telescope and the Cassini and Galileo spacecraft. It looks like Saturn's auroras are also caused by solar winds, but it's not so clear about Jupiter. Despite what you can often see online, the northern lights aren't going to disappear altogether. Once the sun passes its activity peak and becomes less active, both the northern and the southern lights will happen less frequently, but will still be gorgeous. Another beautiful, rare phenomenon is called the green flash. It happens shortly after sunset or before sunrise when the sun is almost entirely below the horizon, and the Earth's atmosphere bends and scatters light from it. People mostly spot it over the ocean. It can also be yellow, blue, or purple. About once a year, you can spot a rare firenado in the US. Fire tornadoes start when a strong wind picks up heat from a fire. They are made of a flame or ash. They're different from regular tornadoes because they don't start from cyclones. Firenadoes are about as tall as the Leaning Tower of Pisa. Unlike firenadoes, fire rainbows or rainbow clouds don't cause any damage at all as they don't have anything to do with fire. You can only see them when the sun is very high in the sky, and its light is passing through ice clouds, so they're pretty rare. The rainbow halos are just as unique. Again, it takes a specific type of ice crystals in the clouds of the surface of the Earth to bend light from the sun into a perfect ring. The same thing can happen with moonlight. The only difference will be that the moon halos are usually white, and sun halos can be rainbow-colored. A white rainbow is another rare illusion, this time created by fog and water. Like a usual rainbow, it's formed when light is shining through droplets of water. It loses color because fog droplets are hundreds of times smaller than those of rain. A white rainbow is sometimes mistaken for a moonbow. You can spot this one at nighttime as the moon illuminates it. That's why it's not so bright. If you ever see an upside-down rainbow in the sky, that's a circumzenithal arc. It's not really a rainbow, but a kind of halo like those around the sun or the moon. This optical phenomenon is caused by ice crystals in the upper atmosphere. You have the best chance to see a circumzenithal arc when the sun is rather low in the sky. It happens super rarely, but it can rain without a single cloud in the sky. It's sometimes called a sun shower because it looks like the rain is falling straight from the sun. In reality, rain clouds are at a distance from that specific location. With sun rays being angled, the clouds become out of sight. Then, it takes just a little wind to blow the rain in your direction. If you ever travel to regions with high altitudes, you might see something called penitentes. Those ice spikes form only in a really cold and elevated environment where the air is dry. The sunlight turns ice directly into vapor instead of melting it into water. That's why these blades of snow and ice up to 15 feet tall start to pop up on the surface of the Earth. One of the rarest types of clouds is lenticular clouds that look like giant mountain hats. They're formed when moist air travels over a mountain or a mountain range and gets into an area of turbulence. Volcanoes can produce bolts of lightning. They're formed in columns of volcanic ash through friction and static electricity to connect the positively and negatively charged particles. To understand how it works, you can rub a balloon across your hair or your feet across a carpet and then touch a metal doorknob. Once a year, just for a few moments, a waterfall in Yosemite turns into a fireball. In winter and early spring, two streams flow down El Capitan Mountain. In perfect conditions in February, when the sun is hiding behind the horizon, it gets into the right position to reflect off the wall and color the water into fiery orange.
Let's head to the Middle East. There's a large desert here, and it's completely dark, except for one spot. It's a big circle that glows with a bright orange light, the Darvaza Crater, and it's just a giant gas burner. Years ago, geologists found gas here, and they started mining for it. But when they excavated, they came across a void underground. The void collapsed, and it formed a crater. It's as wide as half a soccer field and as deep as a 5-story building. Gas began to come out of the cracks in the crater, and since animals were often grazing near this place, the geologists decided to set these gas streams on fire to exhaust the source. Geologists thought the fire would be over in a day or two, but if you come here now, you'll see this gateway to the underworld is still burning, and it's been going on for almost 50 years. In 2013, a man descended to the bottom of the burning crater for the first time. He collected many different samples there, and scientists were able to find bacteria that aren't found anywhere else on Earth. They're quite comfortable at the bottom of this endless burning frying pan. In 2009, a man in L'Aquila, Italy, saw flickering lights dancing above the stone street. He immediately knew what to do and moved his family to a safer place. Only seconds later, a massive 8.3 magnitude earthquake hit the whole region. His knowledge of the strange lights saved his and his family's lives. So, what are those mysterious warnings? For centuries, people interpreted the lights as something otherworldly. The scientific community didn't take them seriously, just put them down to a false recollection, a mind trick, or pure imagination. With the introduction of surveillance cameras and smartphones, the amount of evidence grew enormously. Now the connection was obvious. Lights appear and an earthquake hits. So, experts finally started taking it seriously and started digging for the truth. But after years of research, to this day, geologists are still not fully sure what the source of the lights is. But they have recognized 5 types of them. Bright flashes that light up the sky, looking like storm lightning or a strong camera flash. Rays in the sky that can look like light columns. Different sized flames that come through the ground. Diffused glows over the mountains. And slow-moving balls of light that can be misinterpreted as ball lightning. Another equally little understood atmospheric phenomenon. These are literal balls of lightning that can float and explode, leaving a sulfuric odor behind. But unlike ball lightning, these spherical EQLs seem to be harmless, if you don't count what's coming afterward. But with all these types of lights, experts can't know how exactly they're connected to earthquakes. They don't only show up before one hits. Some have been reported during and after earthquakes. They can also appear with other phenomena, like meteorite crashes, volcanic eruptions, or auroras. For now, scientists can only come up with theories to explain the unexplainable. One of the recent ones claimed the lights were electric lines being broken during an earthquake. But this theory doesn't explain how the phenomena was observed hundreds or even thousands of years ago. like the ancient Chinese tale of dragon-looking clouds appearing in the sky as a warning of an upcoming quake, or how an ancient Roman historian reported huge flame-like lights bursting out just before a huge earthquake occurred. The electric line theory was quickly dismissed. Another theory suggested it was escaping gas. During an earthquake, the underground rocks expand and shrink under pressure and heat. This opens and closes small spaces between them. Different gases make their way through these new openings. Radon, for example, can get released during seismic activity. It can ionize the air, making it electrically charged. But radon doesn't do it enough to create bright sparks of light. This theory is close, but doesn't quite hit the mark. One of the most accepted theories is that it might be from electricity traveling up from underground. When underground igneous rocks, ones that form from magma deep within the earth, are under stress, they release ionized, or electrically charged, oxygen. It travels through the surface and up into the atmosphere, where it creates a localized electric field. That can produce brief flashes of visible light. Some aren't even that quick and can go on for minutes at a time. So, there you are. You've been driving for hours through the night. You didn't have any chance to sleep, so your mind is hanging by a thread. You stop the car and go out to stretch your limbs. And then you look up into the sky and see a beautiful sunrise. Whoa, wait! There are 3 suns in the sky! You rub your eyes, but nope. There are still 3 bright stars in the sky. No, our home star hasn't been torn into 3 pieces, nor has it been visited by 2 other stars. This is called a sundog. It occurs mostly during severe frosts. Small ice crystals in the sky bend the light. As a result, you may see 3 bright spots in the sky instead of just 1. This phenomenon is officially called a halo. Usually, it's just a circle around the sun. You can even see a halo at night, too. Just look at a street lamp, and you'll see a bright circle around it. Sometimes, a halo can take on a fancier shape. If there's a lot of ice in the air, the light is warped even more, just like in a room with a dozen mirrors. Then, the halo can take on the shape of a human eye. Because of this phenomenon, a false dawn can occur too. While you're looking at the horizon, the dawn begins, and the edge of the sun appears. A little bit more, and wait, the sun starts to just dissolve in the sky. After a few moments, it's dark again. And only a minute later, the real sun shows its face. It was the same light curvature effect you saw before with the 3 suns. Only now, the light is curved vertically, not horizontally. And instead of the real sun, its reflection in ice crystals in the sky appeared. And now moving on. This cloud looks like a dinosaur, and this one looks like a cat. And this, whoa, it looks like these clouds are falling down. Oh, phew, that's just a mammatus cloud. Their shape really makes them look like chunks of cloud about to slam on the ground. Well, that's not going to happen, but you better start seeking cover anyway. Such clouds are a sign of a severe thunderstorm coming. It takes a lot of moist air with ice crystals at the top and dry air at the bottom to create such clouds. Then, vertical currents of air appear between these layers. And these currents make the clouds take the shape of a human brain. And this giant cloud looks like a dome that's going to cover an entire city. In fact, that's exactly what happens. A huge cloud covers a large area and then rains heavily on it. Sometimes, the front of such a cloud takes a bizarre shape, like in these pictures. It looks more like several giant spaghetti clouds, or even giant cloud worms. This phenomenon can often be seen in Australia, and it's called morning glory. It happens because a strong wind twists part of the cloud on both sides, and then the huge sheet of air dough splits into thick strips. And sometimes you can see clouds in the sky made of birds. Wow, that cloud moves quickly and changes shape. It becomes more transparent, but then denser and darker again. The birds seem to be involved in some kind of dance or performance, but they're not doing it for beauty or for the crowds of spectators gathered below. They're doing it for protection. When birds group themselves into such a cloud, they intimidate birds of prey. An eagle or hawk would have a hard time picking out a single target among the endless number of birds. And they move quickly, covering each other. Fish are huddled together in schools in the same way. Such a cloud might just spook a hungry predator. Grab some sunglasses and you're good to go. This phenomenon lasts around 40 minutes. These clouds are the same ones that can cause a spooky ring around the moon at night sometimes. Nature sends early signs of disasters in many different ways. J-shaped trees might mean there's a landslide coming. Since the ground is moving slowly, the trees grow into this super selfieable shape. Try to find a flat area and avoid going near any trees unless you have superhuman strength. Another mystical phenomenon can be seen in the desert, a sand waterfall. When the wind brings a lot of sand to the edge of the canyon, it begins to fall down. Now amplify this effect 100 times and you get a sand waterfall in Saudi Arabia. It's really like Niagara Falls, only there's not a drop of water. The locals say this phenomenon warns of an impending sandstorm.